All right, good morning, guys. So today we're going to continue with our graphing. We're going to be looking at graphing what we call vertical and horizontal lines, right? So hopefully we know what these words mean, right? So vertical, we could think about on the coordinate plane is going up, down, or north, south, and horizontal lines are going to go left, right, or east to west. So let's start with a little review of our linear equations here. So it says graph on the same plane. So I'll make my table here, and I'm going to graph this first one, right? So when I substitute for negative x, right, negative 2 becomes negative 2, which is positive 2 plus 3 is 5. And negative 1 is the opposite of negative 1, which is 1 plus 3 is 4, and 0 plus 3 is 3, and then 2, and then 1. So I'm going to plot negative 2, 5. I'm going to plot negative 1, 4, 0, 3, 1, 2, 2, 1. We can keep going. And we can keep going in the other direction if we want. We take out our ruler, and we're going to connect our points. All right, we're going to make sure we draw through that last point and then put an arrow. Draw through this last point and then put an arrow, and we're going to label on the line, or near the line at least. And we're going to do the same thing with the second one, right? Y is equal to 5x. So this should really be a pretty easy one to come up with our table. I'm just multiplying my x values by 5. So 5 times negative 2 is negative 10. 5 times negative 1 is negative 5, and then 0, and then 5, and then 10. So we've got negative 1, 5. We've got 0, 0. We've got 1, 5, right? The other two values, if you have a 10 by 10 graph, you can fit them all. My graph here is only 7 units by 7 units, so I'm not going to be able to fit those other values, which is perfectly fine. Right, that's where we place the arrow. Right, the arrow tells us that this line will continue past where it appears to end, infinitely in both directions, and I'm going to, again, label somewhere on my line. All right, now before we get to the vertical and the horizontal lines, which is actually going to be a pretty quick lesson today, just something I want to recap or review from a few days ago. Right, what happens if, instead of like the do now, where I've got these equations solved for y, they're not solved for y. So the reason we did that lesson on literal equations was specifically so we can solve for y. So if I want to solve this equation for y, I'm going to divide everything on both sides by 2. So 2y divided by 2 is y, negative 6x divided by 2 is negative 3x, and positive 10 divided by 2 is positive 5. So I'm not going to actually graph that. We just did some graphing review. But I just want to keep trying to reinforce the concept of if it's not solved for y, we have to divide by the coefficient of y, or if it's a fraction, multiply by the reciprocal, and then we can graph it. And we'll do one more. And this is the harder one. Okay, what are we doing? We're solving for y, so we're dividing everything by 3. So 3y divided by 3 is just y. What happens when we do 4x divided by 3? Well, 4 is not evenly divisible by 3, so we will leave it as a fraction, right? We're not going to put 1.33333. That would be very silly. So we're going to leave that as a fraction, and then 15 divided by 3 is going to give us positive 5. All right, so let's talk about our vertical and our horizontal lines right now. So the first thing we're going to do, right, I could just give you the rule, which is on the bottom, that we're going to derive. But I feel like we get kind of more meaning out of it by deriving these things on our own. So let's take a look at my table, right? Let's think about what we've been doing when we were graphing linear equations and even quadratic equations. We were making a table, and we were filling in our x values. And then we were substituting to find our y values. Now that's going to be a problem here, right? Because I can't substitute. There's no x value. So I'm going to say, well, let me look at my table. And my equation says that y is equal to 3. Right? There's no place for me to put x. It just says y is equal to 3. In other words, y is always equal to 3. So what does that mean? It means that if x is negative 2, y is 3. And if x is negative 1, y is 3. And I'm sure we can figure out the rest of this. Okay, so we don't care what the value of x is as long as the value of y is 3. So we've got negative 2, 3. I've got negative 1, 3. Now what would happen if x was 7? Well, y would still be 3. What would happen if x is negative 5? Y would still be 3. What about if x was 4? What about if x was 10? So what we're going to see is this is the connection of all the points in the coordinate plane, all the ordered pairs that have a y-coordinate of 3, right? 5, 3, 2, 3, negative 1, 3. So we can connect those points. And we can label it. Y is equal to 3. So let's fill in the information at the bottom, which you're going to put in your notes, because this is going to be our guide for what we're going to do today. The graph of y equals 3 is a, well, that's called a horizontal line. That goes through 3 on the y-axis, right? That's our kind of focus here, that point of 3. So a fast way to do this would say, okay, if y is equal to 3, let me go to my y-axis. Let me go to 3 on my y-axis. And I know that if it's in the form y equals some constant, it's going to be a horizontal line. Okay, well, that shouldn't be too hard. We're not even going to need really the table after this. So let's look at another case, right? X is equal to negative 5. All right, so I've got x, I've got y, I've got x is equal to negative 5. So let me start on my table. All right. It looks like I've got a problem, right? So my equation says x is negative 5. But right now my table has a whole bunch of different x values, negative 2, negative 1, 0, 1, and 2. So I realized I made a mistake. Right? My equation says x is equals negative 5. X has to be negative 5. Well, I have to change things around then. All of my x values as a result have to be negative 5. How about my y values? Well, I don't have any restrictions on my y values. Right? All they're telling you is x has to be negative 5, which means y can be anything. It could be negative 2, it could be negative 1, it could be 0, it could be 1, it could be 2, it could be 7, it could be 15, it could be negative 30. So let's see what this is going to look like. If I plot some of these points here, and I can plot a few extra, right? X is negative 5, y is 5, x is negative 5, y is negative 7. Let's connect the points and label, and let's see what we have. Okay, so let's fill this in. The graph of x equals negative 5, that's what we call a vertical line. And it goes through right here. Negative 5 on the x-axis. Well, that's pretty reliable then, right? If x is negative 5, you go to negative 5 on the x. We put a point there, we make a vertical line. And if y equals 3 or any other number, let's say y equals 3, we just said you go to 3 on the y-axis and make a horizontal line. Well, I'm hoping then we can avoid this process of making the table. Y equals negative 6. Okay, so let's go to the y-axis and go to negative 6, which is here. And we know that y equals some constant should be a horizontal line based on the first example. And if you're not sure, think about it. Say, well, what happens if x is 5? And you can say, well, if x is 5, y is negative 6. What if x is negative 2? Y is negative 6. Now, we don't actually have to put those points. In other words, if you go back, if you've got this in your notes and you refer back to your notes and you say, okay, I know y equals blank is horizontal and it goes through that point, that's really all you need to do. And we're going to do that for sure for the next one. So I'm going to make this nice horizontal line, right? Y is equal to negative 6. That's it. X equals 2. I'm going to go back to my notes. I'm going to say, okay, I know I'm going to have a point on the x-axis at 2, which is right here. And I know that x equals blank is going to be a vertical line. Okay, well, I don't even need any points now. Right, so there's my vertical line, and I will label x equals 2. All right, now this one's a little odd, right? So, I mean, it's not any different, right? Y equals 0. So I'm going to go to 0 on the y-axis, which is the same as 0 on the x-axis, and put a point. Now, what do we know about equations in the form y equals a constant? They should be horizontal. Okay, let's see what that looks like. So what is y equals 0? Well, it turns out that's just the equation of the x-axis. So if you have to plot y equals 0, again, we know y equals is going to be horizontal. We go to 0, which is what we call the origin, right? 0, 0. And y equals 0 turns out to just be the equation of the x-axis, which means you could probably figure out that x equals 0 is going to be a vertical line right over the y-axis, and that would be the equation of the y-axis. All right, guys, so for your now try, I want you to do these two. Okay, you're going to graph them in your notebook, then you're going to describe them to me. And then we can check them out. So y equals 6, we go to 6 on the y-axis, we make a nice vertical line. And x equals -3, we go to -3 on the x-axis. Oops, sorry. Let's take that back. Look, I make mistakes all the time. Look at that. So don't feel bad for making mistakes. Let's go to the y-axis. Sometimes, apparently, even math teachers get confused on which axis is which. So let's go to 6 on the y-axis. Maybe I'll do this the right way this time. And let's make a nice horizontal line, because that's what we were supposed to do, right? For y equals a constant, it's a horizontal line through that number on the y-axis. Okay, let's see if I do this one correct. X equals -3. Let me find my x-axis, and let me find -3 on the x-axis. And I know equations in the form x equals some constant should go through that value on the x-axis and be vertical. All right, guys, so there's your homework, and I'm going to make it nice and easy. I'm going to let you graph it on the same plane. That means you don't need 4 separate graphs. If you want to, because it would be neater, that's fine. You're going to set up one coordinate plane. I will ask that you label it, right? We should always be labeling, but especially if we're only doing one plane, label, -1, -2, and so on. And you're going to graph these 4 equations, and you're going to label them like we normally would. Okay, so again, one graph, I should see 4 lines. I should see them neatly labeled so I know exactly which is which. Questions, comments, concerns, as always, upload your homework and post your question in the comments on Google Classroom.